All right, so this next example is going to give us a chance to kind of put in practice what we just observed. So here we've got a transformation T, okay, here's the rule. It goes from R3 to R3, and this is how it computes its output vectors from its input vectors. Now, what we're asked to do is to find the standard matrix, not of the transformation T, but of the transformation T inverse. So, well, how do we know T has an inverse? Well, it must, or this question wouldn't have been asked, right? So let's just assume that T is invertible for the moment, and let's try to find the standard matrix of its inverse. So how do you do that? Well, based on the facts that we just outlined, it turns out what we can do is we can first figure out the standard matrix of this transformation T, and then just find the inverse of that matrix, and that will give us the standard matrix of T inverse. So let's do that. So, okay, how do you find the standard matrix of a transformation again? We have to plug in all the standard basis vectors. So what's T of E1? Well, that's T of 1, 0, 0. So plug in a 1 for x1, and then plug in a 0 for x2 and x3. So what are you going to get? You're going to get 1, 0, 0. Okay, so that's the first column of the standard matrix of T. Okay, then what about T of E2? That's going to be T of 0, 1, 0. So we're plugging in a 1 for x2 and a 0 for x1 and x3. That's going to give us 2, 1, and 0. Okay, that's T1 or T of E1 and T of E2. Lastly, T of E3. Well, I think I can sneak this in. That's T of 0, 0, 1. So we're plugging in a 0 for x1, a 0 for x2, and then a 1 for x3. So it looks like we're going to get 3 for our first coordinate. We're going to get a 2 for the second coordinate and a 1 for the third coordinate. So that means the standard matrix of our transformation T, I'll just use the word is because I'm writing this as a sentence. So put these columns together. So 1, 0, 0, 2, 1, 0, and then 3, 2, 1. Okay, so that is the standard matrix of our transformation T. But that's not what we were asked for. We were asked to find the standard matrix of T inverse. So, well, if we want to get that, again, let me run through the logic, okay? Conceptually speaking, what we should do is figure out what the inverse of this transformation is, and then use a similar technique to what we did here to actually find its standard matrix. So figure out what T inverse does, then figure out what it does to E1, E2, and E3 to get 3 columns and put them together to get a standard matrix of T inverse. But it's much easier to just look at this matrix and find the matrix inverse of this matrix. And then the result is going to be exactly what we're looking for, the standard matrix of T inverse. So let's use the inversion algorithm to find the inverse of this matrix. So we'll adjoin it with a copy of the identity. So here we go. And then we're going to row reduce this so that this becomes the identity, and then whatever happens over here, that's going to be the inverse of our standard matrix A. I never really called it A, did I? Let's give it a name so I don't have to keep calling it the standard matrix of the transformation T. If I call it A, then I can just refer to it as A. So carry this to the identity, and then this will become A inverse. Okay, so what are we going to do here? Looks like the first column is already good. Let's figure out the second column. Let's subtract row 2 from row 1 twice. So that'll give us what? The first row is the only thing that's going to change. So we're going to end up with 1, 0. And then if you subtract 2 from 3 twice, you're going to get negative 1. This will still be a 1, but now this will be a negative 2, and then that'll still be a 0. Okay, and then now we're going to need to take row 1 and add row 3 to get rid of that negative 1. And then take row 2 and subtract row 3 twice. And then that'll do it, right? Then we'll be good to go. So what's going to change is row 1 and row 2. And what's going to happen to row 1? If we add row 3 to row 1, we're going to get 1, 0, 0 over here, and then 1, negative 2, positive 1 there. And then for our second row, we're going to subtract row 3 twice. So we'll have 0, 1, 0, and then 0, 1, negative 2. So that means we can say the standard matrix of T inverse is A inverse, which we just found to be this 3 by 3 matrix over here, 1, negative 2, 1, 0, 1, negative 2, and 0, 0, 1. By the way, so I just want to take a moment, like this is done. We've completed this now. This is what was asked for. But note that you can use this, like if you know what the standard matrix is, you can always actually write out a formula, right? If you actually want to write down a general formula for what T inverse does, I'll just include this as a note because this is just above and beyond now what was asked. We could actually write this. We could say T1 or T inverse of x1, x2, x3 is going to be 1, negative 2, 1, 0, 1, negative 2, and then 0, 0, 1 multiplied by the input vector x1, x2, x3. That's the whole point of a standard matrix. And then if you actually carry out this matrix multiplication, what you'll end up getting is it's a 3 by 3 and a 3 by 1 being multiplied. So the result is going to be a 3 by 1. And the first coordinate is going to be x1 minus 2x2 plus x3. That's the first entry. The second coordinate is going to be x2 minus 2x3. And then the last coordinate is just going to be x3. You can check now, if you want, you can check that this function and this function, they cancel each other out. If you apply 1 to an input vector and then take the corresponding output vector and then plug it into the other function, you're going to end up back right where you started. That's the whole point of the inverse of a linear transformation. So what is the point of this note? I just want to emphasize that having access to a rule, let's call this a formula for evaluating a transformation, it's just as good if you have access to the standard matrix. Because if you have the standard matrix, you can always recover a rule like this. So quite often when you're asked to find a linear transformation, you won't, it's usually, it may not use this word, right? Here the wording is find the standard matrix of T inverse. But if it had just said find T inverse, we would have automatically done the same thing by finding the standard matrix. Because as we've shown down here, having the standard matrix makes it just a routine matter to figure out what the formula is for the function.